We have here is ASV, which is adaptive support ventilation, which is a single mode from intubation till extubation, sir. And in ASV, our major input to the ventilator is patient's height, which takes the ideal body weight. Let's say I have a patient of about 196 centimeters, and ideal body weight is 90 kg. It's not necessary for
196
actual.
centimeters is not realistic.
Yes, it may be plus or minus, but we can do a centimeter, and that will give the ideal body weight.
Keep it to
Less.
170.
Yes, sir.
Because most of them are of our height only.
Yes.
190 is like Amitabh Bachchan.
Yes, correct, sir, correct. You can keep it at 170 or whatever you require.
I'll keep my height.
Yes, sir, 168. So which should give you 65 ideal body weight is the ideal body weight as such. Now if I go to controls, this is the ASV controls. In ASV controls, we don't have tidal volume, breath rate or IE ratio. What we have here is only the percentage minute volume, which is 6.5 liters, 6.4 liters, which we have said, PEEP, FiO2, a flow trigger and a pressure limit. And what ASV mode does is, ASV mode will give 3 test breath to the patient, understands whether the patient is breathing, not breathing or partially breathing, what is his resistance, what is his compliance. So based on that, the machine will automatically set the tidal volume, automatically set the breath rate and IE ratio combination to achieve your minute volume. So that it's a minute volume ventilation based on the patient's resistance, compliance and his breathing capacity. Let's say I start the ventilation. Now if I start the ventilator, let's say I start the ventilation.
It's not breathing spontaneously.
Yes, correct, sir. So now when it comes to ASV mode here, now as you could see, the patient is a test line, he is not breathing spontaneously. It is 0 breath from the patient. Now this is called as ASV graph. In ASV graph you have tidal volume versus your breath rate. So and the machine has to reach 6.5 liters. That's the target to the machine. So this 6.5 liters can be achieved with a very high tidal volume and a low breath rate, or with a very high breath rate and low tidal volume. There can be any combination. What machine does is, it has understood that this is the ideal point. Let's say around 300 odd, 280, 300 odd tidal volume, and about 23 is the breath rate. So which machine has understood this is required for this patient at this breath. And the plus crosshair is the patient's condition. And once the patient's condition, it will try to push the patient to the target. And it also has a safety box here, which will try to maintain the patient not to go for a very low tidal volume or a very high tidal volume, ensuring volumetric barotrauma can be avoided. And it will also ensure that very high breath rate or low breath rate will also be avoided, so that you don't have a tachypneic or you don't have an auto-peak development for the patient. Now what happens here is, sir, you can see there is a 23 controlled breath and 0 spontaneous, which means patient is not breathing. Machine has understood that it has to give 23 breaths and around 300 ml tidal volume to maintain the minute volume. Sorry, sir?
We usually keep within 23 is...
Yes. This is an ARDS similar patient. So in that case, it has understood.
For ARDS simulation.
Yes. This is a stiff lung. So let's say ARDS patient. So that's why it has got a pattern where you have a higher breath rate frequency, but tidal volume will be lesser. Now the same way, if the patient starts breathing, what are the changes you can see? The first thing is the tidal volume will go higher.
It will cough now.
Yes, sir.
It's just coughing. Patient is coughing now.
So you can see the spontaneous has increased. Let's say I'm just simulating the patient breathing spontaneously. And as you could see here, the spontaneous is increased and control is decreasing, which means the machine is allowing the patient to breathe and it is not fighting with the patient. So let's say the patient is fully spontaneous. Then you can see roughly about say 20 plus is the breath rate by the patient, and control is 0, which means the machine is not controlling the breath rate now. It is only doing like a pressure support work where it is supporting the patient. And you can see the tidal volume has changed, breath rate has changed, safety box has changed, because the patient compliance has changed. So based on that, the machine will be able to adapt to the patient. Now let's say in a situation where the patient has stopped breathing, what happens? When the patient stops breathing, the patient is still in ASV mode. What happens is, the mode will ensure that again it will give test breath to the patient, understands again the change in compliance.
How many seconds it will take?
3 breaths, sir, which is about, let's say, 5 seconds to 8 seconds maximum. But it will already start giving breaths. But what is the ideal tidal volume? It will adjust for that. But it will already start giving breaths. So now you can see you have a control breath which is increasing, spontaneous is decreasing. So which means now the machine